Hey everyone, it's Justin again, and in this lesson we're going to be looking at how sometimes word problems are best answered using inequalities rather than equations. Here are some common phrases that are used to mark when inequalities might be necessary in a word problem. Some of these we'll use in this lesson, and others you've probably heard in your day-to-day life. Make note of these because whether you're a student taking algebra or an adult making financial decisions, knowing how to express inequalities is going to be important. Sometimes word problems make more sense to solve using inequalities. For instance, if you have a phone plan that costs $20 flat plus 25 cents per text, and you want to know how many texts you can afford with $70, you could set the problem up with an equal sign, in which case the answer would be 200 texts. However, does this mean that you have to send exactly 200 texts? Of course not. If you sent less texts, you just wouldn't spend all the money you have. Instead of saying that you want your phone plan to cost all $70 that you have, you could instead say you want it to cost less than or equal to $70. Then, when we solve it, we get that the number of texts you can send is less than or equal to 200 texts. This is just one example of where the answer being one specific amount doesn't make as much sense as an answer that is within a sensible range. So let's look at another problem, and this time we'll solve it together. Tom plans to take a taxi that charges a $5 flat fee and $0.5 or 50 cents per mile. He has at most $50 to spend. How far can he go? You'll notice immediately that this is another spending money problem. And when spending money, we can spend all the money we have or any amount less. Another clue that this should be an inequality is the phrase "at most." This means Tom is willing to spend up to $50, but that's the most. Absolutely no more. So we should set up an inequality showing that the amount Tom pays for the taxi can be equal to or less than $50. Now we're going to solve by subtracting 5, then divide by 0.5, and we get that m is less than or equal to 90. Does this answer make sense? Remember, m was the amount of miles Tom goes in the taxi. So we're saying that the distance Tom travels can be equal to 90 miles, or any amount less than that. That makes sense because at 90 miles, Tom would spend exactly $50, so he could go any smaller distance and pay less. He just can't go more than 90 miles because then he couldn't afford it. Next problem, Maria gets paid $15 per hour. She knows her bills this week will total at least $195. How many hours does she need to work? So we know how much Maria gets paid, $15 an hour, and we know that she needs to make $195 for bills. So should she only work enough to pay her bills? Of course not. She could work more and have money left over to save or to spend on whatever she wants. So she doesn't just want her pay to equal $195, she wants her pay to be equal to or more than it. Another clue that points towards this lies within the problem "at least," which of course is the opposite of "at most" because it gives the lowest amount possible, but you could always go higher. So let's solve it by dividing by 15. 195 divided by 15 is 13. So we get that the hours Maria works must be greater than or equal to 13 hours. Why? Because at 13 hours, she'll make exactly $195, enough to pay her bills. But if she works more than 13 hours, she'll make more money. One last word problem. A party sender charges $240 to reserve a room and then a fee of $20 per person. Stacy wants to spend below $1,000. How many people can she invite? So we know the room costs $20 per person plus the $240 reservation cost. And we know Stacy's limit. The problem says she wants to spend below $1,000, not up to $1,000, but below $1,000. So is she willing to spend an amount equal to $1,000? No, because 1,000 would not be below 1,000. So we have to be careful here. The amount she pays for the room should be strictly less than $1,000, not less than or equal to. First, we subtract by 240, then divide by 20, And we find that P, or the number of people Stacy can invite, is less than 38. Again, we have to be careful here. Obviously, she can invite less than 38 people, such as like only 25, and she can't invite more than 38. So if she has 50 friends, then some of them will be left out. But could she invite exactly 38 friends? No, because 38 friends would cost exactly $1,000, and she said she wanted to spend less than that. In the next lesson, we're going to be looking at how multiple inequalities can be combined into one, and practicing with at least a couple examples. See what I did there? Get it? At least. I'll go.